Hey guys, welcome back to Daniel's Tech World. My name is Daniel Rosehill. Recently doing some videos about data backup and archiving onto optical media. We're getting into the more complicated topics of checksums. And in this video, I wanted to expand a little bit on using Quick Hash as a way of generating checksums I'm using it for the M disk, but you can use it for whatever you want. Really, wherever you store your archival data doesn't matter. You can, of course, run this from a data stored on a HDD or whatever, really. But what I wanted to show in this video was a couple of ideas for how to use this program to save the hash values. I'm using SHA-256 today. Obviously, you can use whatever one you're most comfortable with. So I ran this on an M disk, a random M disk, and I'm going to use this, even though these hashes are generated now, I'm going to use this as my kind of fixed point in time to have one test M disk and say, how did it actually do that M disk? Is the data corrupting, or is it remaining absolutely perfect as they claim it will be? So one way we can do that is definitely with hashes. So what we are going to do, so I've shown you yesterday how you can use this program, Quick Hash. It's available for Linux, OS X, and Windows. It's free, and I'm running this on Ubuntu. It runs perfectly. So if you don't want to, this gets complicated quickly on the command line. So this is a way to just make the process a bit more easy for yourself. So as you can see, I've generated all the hashes on all the files in the M disk. The M disk was YT1122. November 22, it had 50 or so, exactly 50 actually, MP4s in it, videos, backups of my YouTube videos, some stuff I did for work as well here. And now we have hashed everything. So the usefulness here is that we want to compare the hashes with the hashes at a later date to see did they change. So to do that, we're going to need to save the hashes today. Ideally, you're doing this when you do the video. So the methodology I showed yesterday was a pretty rough and ready one as such. I went for right-clicking on the hash value. Then I went for, let's see, copy the entire grid. And that will just like dump this grid that you're looking at here with file size, hash value, file name, file number onto text. And then what you can do is just pop open your whatever text editor you like, paste, save, and this is what you'll get. The hash is here. The original file path is, I guess, here, hash, file size, etc. Now, as you can see, this is not great to read as a human. It's a little bit confusing. So that is one way, but it does work. You could save this as a TXT file and you could write it onto the disk you're archiving. The disadvantage of that is, well, technically the hash file itself could get corrupted. So I recommended putting it up to the cloud or saving it on your local. Another friendlier, there's two more things I want to show in today's video to go beyond that methodology I showed yesterday. One of them is saving it as a CSV file. This will make it a little bit better. At least you'll get your stuff organized into columns. But this one is really useful. Save to HTML. And you can see I've saved the hashes file. And now I want to show you how that actually looks. And again, you can use this either way. You can put this onto what you're archiving, or you can save this on the cloud or something. And if we're looking to check the checksums, at a later date, like check this disk in 5 years, it would be a lot more useful to have this. So let me show you how it looks like. Okay, so this is what the output of that HTML looks like opened up in a web browser. I'm using Google Chrome here. And we can see a huge improvement on what we had previously. We can see each file has its number. There's the file name here. There is the original file path, which will not be so helpful because, this is just where it was from when the optical media was mounted to my system. But this will be extremely useful. So you can see comparing these two hashes at a later date would be as easy as opening the disk again in 5 years' time or whatever time in the software. And then comparing one by one. You can very easily and quickly do that in Quick Hash. by doing compare to files or compare to. There's definitely compare to hashes in here somewhere, or you can compare the file against the expected hash value. So I could open this from the the M disk. I could go to this file, the Turkish coffee thingy. I could point it to the file and I could say, here's what you expect. Here's what we expect. And hopefully they match, and you can know, okay, great. So that file is completely perfect. That video file is being preserved exactly in archive. Now there is one more thing that you can do when you look at the files option. Going back to this page here, I'll just put my browser away again. You can see there's an option here to load a hash list. So what this is that you can actually store the hash list. You can load the hash list. You could load it from the optical media, or you could load it from wherever, but it has to be in a specific format. And I'll show you what they're looking for. Ensure that your hash list contains just hash values, no other column, no row heading, and ensure you correct the hash to match your imported lists, the right algorithm. So what you want to do, so I don't have one of these. Now what you'd want to do for that is, let's just do this one more time. You just want the hash values. It just wants the hash values, nothing else in a file. So what you would do is right click here and you would go down to copy all hash values. And this will only copy the hash values onto the clipboard. I'm going to bring my clipboard back. And now we have just the hashes. And now we can save that as a TXT file, load that from somewhere. And I believe the first line is just the algorithm. And I believe we would be able to compare that against the hashes we're seeing here. Just finally, to round off this video to show what you can do at the final stage. So on the left, I've taken, for the process of making this simple, I've just hashed out 2 random images in a folder and computed their hash values with SHA-256. And let's say I saved that as a text file according to the first instructions that we showed. What you would do is just repeat that process. Say these were the 2 images on your M disk, and you wanted to do that in 2 years' time, whatever. There are ways to do this using software programs or using command line tools, but just to be lazy or just being lazy, I'm using a website called textcompare.com. There's lots of these there's also one for CSV compare, which would work as well if you wanted to do CSV. But let's say I did text compare. I can just, look later and hopefully we'd be getting a perfect comparison. The 2 texts are identical. But let's just change one value in the hash from an 8 to a 7 in the first file's hash. I'm going to compare it now. And what we can see is that it'll flag the differences. We can say, okay, this changed. And what file was this? This was 200515.jpg. That is corrupted. So if you just want to make it simple for yourself, use one of these text utilities on the internet, and you'll be able to do that. And just to show you as well how the CSV option works. So I did a CSV export on the first file, comma separated value. So we have now some kind of a very basic table format. And I did the second one, but I changed one value again. And I'm going to run one of these online comparison tools. And this might make it easier as well. Because you can isolate it quickly to the row. And you can see here that was image again 515 was the difference. What was different, and it flags that the hash is what changed. So you've got a few options for comparing the state of your M disk between now and a later date. And these, I think, really all work. So just choose whatever one is most comfortable for you. Hope this is helpful. Thank you for watching. Until next time.